I'm going to use this Gravity and Orbits lab to help explain how gravity and inertia keep the Earth in orbit around the Sun. In this model, you can see the Sun is represented by this yellow circle here in the middle, and this is the Earth. Now, the Earth is an object in motion. It has a constant speed and direction. We call that velocity. A constant speed and direction. It wants to travel in a straight line. You can see here, this is the arrow pointing in the direction the Earth would like to travel. It's going a constant speed and direction or velocity in this direction. However, the Sun has a great force of gravity. It has a great mass, much greater than the Earth's mass. It causes an attraction that pulls back on the Earth. So here we can see the Earth's gravitational force and the Sun's gravitational force attracting each other. Newton's law of universal gravitation says all objects in the universe attract each other. So these two objects are attracting each other. If I play this model, you can see that the Earth is being pulled back by the Sun's gravitational force, and instead of flying off in a straight line, travels in a circular orbit. Now, the Earth has been traveling this way since the beginning of the formation of our solar system. If something were to change the gravitational force, it will also change the Earth's orbit. And we have learned that gravity is affected by distance and mass. So if we were to decrease the mass of the Sun or increase the mass of the Earth, that's going to affect the gravitational force and therefore affect the orbit of the Earth. If we were to change the distance between the Sun and the Earth, that would also change the gravitational force. So you can see as I pull the Earth away, the force of gravity decreases. As I pull the Earth towards the Sun, the force of gravity increases. And we can look at these different models to see what would happen. So let's start with moving the Earth away and watching the path that the Earth takes. Now it wants to go in a straight line. Sun's gravity will pull it back. If it's too far away, that gravitational force may weaken enough for the planet to escape and leave the Sun. Now it looks like the Sun's still pulling on it a bit. If we decrease the mass of the Sun, we also decrease the gravitational force. If you decrease it enough, it might cause the planet to fly off because of inertia, object in motion, in a straight line off into space. So by using this model, we can see that both gravity and inertia is what keeps our Sun, Moon, Earth, and all the other planets in orbit.